Hello and welcome everyone. As scheduled, we are going to start the second session on electricity and electromagnetism. Today is the second session. I hope many will join after some time, but we will have to start at the scheduled time. Good morning, everyone. This is SS Tripathy welcoming you. This is the Uranium platform from where our job is to motivate the school students for a career in physical science. Particularly, we are interested in physical science, but we also encourage students to chase their passion, maybe to become a doctor, a biologist, and whatever possible that is in their dream. Now, let me share my screen without a delay. This will be recorded and it will be watched in a later time by many, because I will be within minutes from now, within maybe max 45 minutes from now, we will discuss the entire set of topics that we had planned for today. That is magnets, magnetic field, and the magnetic field by a current, and the force exerted by a current carrying force exerted by a magnet to a current carrying conductor or a moving charge. The principle of motor. Now, be sure that I will be using the Odia term off and on. Whenever I feel that you are unable to understand, then I will definitely use the Odia terms and also talk in Odia. But I always encourage, particularly to the class 10 students, to listen to lectures in English. That will help you in the long run. Is there anyone watching from remote places in YouTube video now? Could you please write a line in the chat box to make me feel that someone at least is watching remotely in the direct live streaming in the YouTube. Now, you all know and participate in our discussion. You can ask a question to our physics expert. Will be joining very soon, Dr. H.K. Mishra, Hementa Kumar Mishra, who must be watching remotely, and he'll be joining very soon. You know, there are so many types of magnets. Chumbaka, like Danda Chumbaka, Ashok Khurakruti Chumbaka, bar magnet, horseshoe magnet, U-shaped magnet, disc or circular magnets, ring magnets, and most importantly, compass suchi, magnetic compass or magnetic needle. And compass needle ro north pole सबुबले पृथ्वी रो north pole दिगरे oriented by directed ही था, and compass needle रो south pole पृथ्वी रो माने geographic south pole संगरे aligned है कि सबुबले था. And as you know, there are these are the two magnets, south pole, north pole, they attract, north pole, south pole, they attract, and that is not unknown to you. And these are some of the iron powders. Luha gunda sabu sprinkle kara jaichi, and these luha gundas, iron powders, they have been aligned in the direction of the magnetic field. A magnetic field has a particular direction at a particular point, and the magnetic field strength is maximum near the poles, and they are little less, and they are different at different places. To know को जगह magnetic field रो strength केते हमें imaginary lines of magnetic field lines हमें करू, magnetic lines of force বা field lines हमें तैयारी करू, those are imaginary, काल्पनिक. Only to know that a point रे tangent कटिले, that will give you the direction from south to north, north to south. The direction is always from north to south. So we have, this is the bar magnet. North pole it is because when you align it, when you suspend it, bar magnet, the north pole will be oriented, directed to the geographic north pole. Seiti janigalo je seta hala magnet ro north pole, and the south pole of the magnet will be oriented to the south pole, Antarctica direction. These are some of the different types, and this is our favorite compass needle, because I will be using a very interesting pointer highlighter today. This is my debut use of this pointer to point moving these different places. Now this is the Earth's magnetic field. The Earth's magnetic field, the north geographic pole is near the south pole of the Earth's magnet, and vice versa. This is the Earth magnet, and the axis of rotation जो अक्षरे से बुलुची दिन राति होची सेही अक्ष थारु मैग्नेटिक एक्सिस जोटा साउथ पोल नॉर्थ पोल एक्सिस 11 degree inclination तार अछि. It's not, we say that it is near the south pole of the Earth magnet is near the geographic north pole. This is the geographic north pole, but it is not exactly oriented towards the geographic north pole, slightly tilted. And geophysics is a great physics. So if you ever study later geophysics, you will know how magnetism develops and where it is maximum, and it is maximum in the earth crust, and how it changes with the depth. All these details you will know when you know. And could you believe Earth magnetic field strength kete koilo is so small in terms of Tesla? It is 0.4025 to 4065, or in terms of Gauss, it is 0.25 to 0.65 Gauss. On the other hand, amar gute horsu magnet ki auri strong magnet, sadharano magnet, that is about 100 Gauss. So it's much stronger than Earth. As a magnet, it is so weak. So Pritam, you had asked a question. If Dr. Mishra is listening to me, his question was, when something, supposing you take an iron piece, iron, which is a ferromagnetic material, lauha chumbakiya vastu, taku jodi upuru chhadiba, se jo toluku poduchi, is it due to the gravitational pull or due to the magnetic pull? Because iron is a magnetic material. It's not a magnet, but it's a magnetic material, ferromagnetic material. It can be magnetized, can be. The answer is, it is predominantly, almost exclusively by gravitational force, because the magnetic force is very little, which is unable to attract an iron piece. It is the gravitational force which predominantly is responsible for attracting even iron, cobalt, nickel, the ferromagnetic substances. And there are some natural magnets which are found in the earth crust, such are lodestone or magnetite, some pyrite materials. These are the natural magnets, but but they were discovered many years before, and they were used in many places, particularly in magnetic needle. They are used, the lodestone. But we are more interested in artificial magnets which can produce strong magnetic field. Iron, cobalt, nickel, gadolinium, chromium, 4 oxide, and many others are called ferromagnetic materials, which can be magnetized. And that process of magnetization is called magnetic induction. And you can convert it to either a permanent magnet or a temporary magnet. You can do that. Now, this is a very simple thing that I told you that this will be a revision program, not that we'll be having 3 lectures to cover this. Now, you know how to map out the magnetic lines, the field lines. Magnetic field lines can be mapped out. Supposing this is a bar magnet. Welcome, Dr. Mishra. You should change the name. That his name is your daughter's name. Please make it Dr. H.K. Mishra, please. So let me continue, and let me introduce. We are joined by a very talented professor of physics who was just recently retired, and he is our uranium core member, physics core member, expert in physics. So we have Dr. Mishra with us, and I salute and I pay my greatest respect to my physics teacher, whom I learned ABC of physics. I have my all adoration, my respect to him, Babaji Charana Mishra in Ravenshaw College. And during my uranium journey from 2002, my teachers were Dr. S.K. Mishra, Hementa Kumar Mishra, and Bhimsen Panda. Those 2 professors are our core members, and I never miss an opportunity to attend to their classes when they take classes for teachers training program or students camps. I used to sit beside particularly teachers training program, where teachers are very keen to ask very interesting questions. So I attend their classes from start to finish. So that also made my curiosity and my passion for teaching physics for lower level students. I don't have access to higher than class 10, as I have told you, and I have invited Dr. Mishra just to watch. If I commit any mistake in a conceptual level, feel free to correct me at the end of our program. When I leave after 40 minutes, and there will be a discussion, question answer discussion, then he will rectify my mistakes. Now see, this is a bar magnet, and we can map out the lines of force, or we call it field lines, by using a compass needle, and starting from the North Pole and following these traces, points, and then joining the points, and you find that the lines are concentrated near the poles. So the magnetic field strength is maximum near the poles, and they become less as you go away from the magnet. Now this is the same thing. The magnetic lines of force are from the North Pole to South Pole. and we draw these lines with the help of a magnetic needle. And you must have done in your school, maybe doing in your school, that put a paper and then cardboard or any paper, then put the magnet, and then take a compass needle and then start from the North Pole, and wherever it is pointed, that is the direction of the North Pole. You again put a dot and put the South Pole, and in this way you ultimately come in a circular manner, or sometimes you don't, because it go away, then it will make a circle or elliptical path a long distance. You just leave it. Or you do go to the larger distance, you will find it will be a larger elliptical path, so you can draw it. You can also visualize it by taking a bar magnet on a paper and sprinkle the iron dusts. Luha gunda jodi phopad dabo, empty random phopad dabo, se oriented hejibe in a manner that will be very interesting to see. That will give you the direction of the lines of force, or it is more importantly called magnetic lines, magnetic force, line force, magnetic field lines. I'm sorry. Now the magnetic field at any point will be found, the direction will be found by drawing a tangent, of course, towards the direction of North Pole. It is coming from north to south. So it is supposing here you put a tangent, so it is from north to south. This direction, in this direction will be, at this particular point, will be the direction of the magnetic field. Now you must remember that these lines of induction is a imaginary creation. To get the understanding of the magnetism, this, the entire lines of induction coming from north to south, temporarily, imaginary level we have done it. So that is called the flux. And if you take a uniform area perpendicular to it, then the flux per unit area perpendicular to it, that is called the flux density, or this is called simply the magnetic field strength. Or sometimes we love to say magnetic field. Whenever we say magnetic field strength, it means B. B is a very powerful word in magnetism, which is the total number of flux passing through a unit area perpendicular to it. But the area can remain in an inclined manner, so that there is an angle between the direction of the magnetic field and the area. Remember, area is a vector quantity. It's called area vector. That area is a vector quantity. Those who have not been exposed to the fundamental concepts of vectors, I request them to join in our October Puja vacation program for class 9, just to have an idea about more about vectors, so that in class 11, which is coming very soon, you can enjoy it. Now, so this is the unit area, and unit. But actually, if there is an angle between the area vector, remember the area vector, the magnitude is the area, but the direction of the area vector, that plane surface, is perpendicular to the plane surface. That is the definition of area vector, right? So actually it is a dot product. There are two types of product of vectors: the dot or the scalar product, and the second, the vector or the cross product. So here we take the dot product, so that when we take the magnitude, it becomes BA cos theta. And area vector, I have told you the direction is perpendicular to the plane surface. Now therefore, when there is an inclination between the the direction of the field and the area vector. So if this is actually, this is the direction of the area vector, as I told you, is perpendicular to the plane surface, and this is the direction of the field, this angle is theta, then the flux is equal to BA cos theta. And therefore, when the area is perpendicular to the direction of the field, then the flux is maximum. That gives the greatest benefit, because you know the area vector has the direction perpendicular to the plane surface. So the direction of the area vector and the magnetic field is same. The phi is equal to 0. So cos 0 is equal to 1. So maximum flux is being experienced by a surface which is perpendicular to the magnetic field. And if it is, you know, parallel to the magnetic field, but the direction of the area vector is perpendicular, so the angle is 90 degrees, so there is no flux passing through that particular area, so there is no effect, there is no magnetic effect, and so on. So thus we go to the next program, that is magnetic field due to current carrying conductor. You know this, that whenever you have a complete electrical circuit, this is a copper wire, and you put a magnetic needle, it will show deflection. Earlier, it was in the direction of geographic North Pole, South Pole oriented. But once you bring near to another magnetic field, then it will interact with that field, and the Earth's field will have negligible effect on the compass needle. So this will listen to the commands of this magnetic field. From this, it was proved that yes, current carrying conductor is also producing magnetic field. It is not a current. Yes, it is a current, and it is giving electrical benefits, electrical work done, and you convert it to several heating effect and light effect and so on and so forth. But it is also producing a magnetic field. And you know, when we keep a compass needle below a straight current carrying conductor in a loop, in a circuit, and the current is flowing from the south direction to the north direction, then the north pole will be deflected, bikhepito hojibo west direction re, and tame jodi ta upare rakhibo, say south ru north direction re jibo current विद्युत स्रोत, ताहले कोन होबो ना नॉर्थ पोल टा ईस्ट को विक्षेपित होबो. ठीक उल्टा काम होबो जदि तुमे साउथ रु नॉर्थ रु साउथ को जदि बैटरी रो पॉजिटिव इलेक्ट्रोड टा को उल्टेई दबो, नेगेटिव संगे उल्टेई दबो, ताहले कोन होबो ना डायरेक्शन इज फ्रॉम सपोजिंग नॉर्थ टू साउथ उल्टी होला, then opposite thing will happen. North pole will be deflected towards the east, and tole rakhile ta upare rakhile the north pole will be deflected to the west. Yar thik ulta ta. So this can be understood very easily once you know how the two magnetic fields interact, because there is interaction between the magnetic field created by this current and the magnet which is present in the magnetic needle. Most of it is made up of lodestone. It's a very weak magnet, is lodestone, ferrite materials that has a very low magnetic strength that is required. And you know how to know the direction or map out the magnetic field lines by using the Maxwell right-hand thumb rule. So when you are showing तम बुढ़ा अंगूठी जदि तमे करंट डायरेक्शन रे देखैबो, ताहले तम अन्य अंगूठी जो आडे कर्ल करि जीवो, राइट हैंड रो कर्ल करि जीवो, सेटा हबो the direction of the magnetic field. Or you can draw, you can map out. गुटे बोर्ड रे गुटे सर्किट रो गुटे स्ट्रेट कैरिंग कंडक्टर को फुटेई करी सेपटे बाहर करो. सो ए पटे जाउची the current in. So इठी in हेले एठी गोटे क्रॉस साइन दिया जाए हम पेपर रे लिखिबा गोटे क्रॉस साइन देला माने करंट इन एंड डॉट देला माने करंट आउट सो आमे तो चित्र फित्र करि परिबानी हमकु हैव टू शो इट इन अ वेरी कंडेंस्ड मैनर सो क्रॉस माने द करंट इज गोइंग इन dot माने the current is going out now we can also plot by the help of the magnetic needle and following its direction the north direction will be always pointed upward so then put a dot and then you continue to follow so that you can visualize the Maxwell corkscrew rule or the right hand rule that right hand thumb जदि करंट डायरेक्शन रिप्रेजेंट करिवो ताले अन्य सब गुडा आंगुली जो डायरेक्शन रे कर्ल करिवो बुलेइबो सेटा होची मैग्नेटिक फील्ड लाइन्स रो डायरेक्शन एटा एमती अछि बिली एमती अछि यदि एमती जाई थांता एमती ही थांता सो दीटा को केस हमें देखै जाइछे एटा ऊपर को जाउची आउट माने एठी क्रॉस दिया जीवो सॉरी डॉट दिया जीवो डॉट माने डॉट माने हमें एठी करिचे डॉट माने आउट मो शॉर्टकट रे मन रखिया कि डो सी डॉट माने इट इज कमिंग आउट ऑफ द प्लेन एंड सी आई डो सी करंट इनटू द प्लेन सो क्रॉस माने भीतर को जाईची डॉट माने बाहर को आछी सो व्हाट आई वाज हियर टेलिंग यू वेल यस एठी ऊपर को जाउची माने डॉट एंड एमती जाउची माने ए देखो मैग्नेटिक फील्ड्स रो डायरेक्शन इज सर्कुलर these are the circular field lines for a current carrying conductor so also here but the directions are opposite एठी जाईची तो ऊपर तळको क्रॉस into the board so एमती so this is clockwise and of course you find a mistake here the copy paste that I have made from some source you find the directions are shown same it is wrong so if this one is correct it is going up this is my right hand so it is going anti-clockwise it is okay this is simply okay but this one is wrong because this is going in the downward direction like this so it will be in the clockwise direction so this would be this and this right so it doesn't matter once you know the concepts then there will be no problem now coming to the what will be the strength at a particular point supposing this is a straight carrying conductor carrying a current I then at point P what will be the strength of the magnetic field that is it is directly proportional to I the current and inversely proportional to distance I by D and the proportionality constant contains a very important word and I would request Professor Mishra to expand more on this particular term mu not now when he comes and takes over from me this is called the permeability of the medium and sometimes most of the time the medium is air or vacuum they have more or less same permeability now what is permeability as an ordinary person to me that medium to what extent it can be magnetized or it can carry the flux the more flux it can accommodate carry take allow to pass the more I'll tell you later the magnetic domains are aligned and it will be magnetized so more is the permeability of the medium more is its tendency to be magnetized it is allowing more flux from the source of magnet through it and it will be more easily magnetized for example if you take the relative permeability of air as 1 then can you imagine soft and pure iron which is annealed in presence of hydrogen pure iron 99.9% pure iron annealed iron has a relative permeability 2 lakhs. Can you imagine? It is 2 lakh times more effective in becoming magnetized than air. But we don't need so much of high permeability for our temporary magnet preparation. The reason Dr. Mishra will explain why we select a low permeability material for having our magnets. I mean, artificial magnets, not very high, like 100% pure iron, having very high permeability. Now, I have already explained permeability, and this is Tesla. Magnetic field raw, jo field strength raw, jo unit hochi Tesla. That is the SI unit, but tar gote kuni unit hochi Gauss. So Tesla is defined as the field intensity or field strength which will produce at a distance of at any distance, when 1 ampere current pass through that particular conductor per meter. The length of the conductor will be 1 meter and the current passing will be 1 ampere, and any place where it is producing 1 Newton force, then that quantity is called 1 Tesla. So 1 Tesla is defined as the field intensity. That is the field intensity which generates 1 Newton of force per passage of 1 ampere current per meter of the conductor, and its unit is called newtons per ampere per meter. A definition it is Newton per ampere per meter. You can also split down to kg per second square per ampere. Now m is the distance unit meter. This is A is current ampere, and permeability unit hoji Newton per ampere square or Henry per meter inverse. We will ask you, Henry has come from other source. Inductance unit hoji Henry. So Henry per meter is a very popular unit for permeability. Newton per ampere square popularity ette nahi, but everyone talks about Henry per meter, and I have shown you how Henry per meter is same as Newton per ampere square, right? And this is a circular current carrying conductor. That was a straight carrying conductor we talked about. This is a circular current carrying conductor. The same right hand rule or corkscrew rule can be used in the opposite manner. If all other fingers will point the direction of the circular current, then the thumb will represent the direction of the magnetic field. That the magnetic field is exactly, pointing straight in the center, but in all other places there will be slight curvature because it will be circular. But if you look to any straight region, this is the straight region, this is the straight region, you can use the concept of straight carrying conductor like this to know the magnetic field lines and draw accordingly the magnetic field lines near this portion where it is piercing through the cardboard. A portion re jodi tame chahibo kamti na circular habo eta clockwise and anti-clockwise, eta emti jauchi toluku jauchi, eta upuruku jauchi, and मझिरे जदि बाहर करिवो ताहले एठी तमे उल्टा डायरेक्शन रे तमे राइट हैंड रूल राइट जो डायरेक्शन रे बर्तन करंट जाउची से डायरेक्शन हले ए डायरेक्शन रे एमटी जाउची एमटी and I'm happy to welcome Devidatta Brahma from Sambalpur and Akanksha Priyadarshini, better late than never, and Aratrika Rudra as usual. And make sure that while I am delivering fast, because I told you I have 3 independent lectures which will be, abreezed in 45 minutes. So I had told you to see those things, and this is a revision program, and we will invite the experts to clarify our doubts. Now, this is already done. Now, how to find out? That the interesting question was posed by Pritham. How to find what is the field at the center? When I said field, I mean field strength, flux density B. At the center has a different formula. This is the current passing through the loop, the circular loop, and the radius from the center. So mu naught, this is the permeability of the empty space or vacuum, which you have to remember is 4 pi into 10 to the power negative 7. What? Who can tell me? What is the unit of permeability? It is, to me, it is Henry meter inverse. I mean, I like that. So this I have to make it mu r, relative permeability. Where is that? Okay, forget it. This should be mu r. Relative permittivity of pure iron is 2 lakh. And somewhere I had given the, yes, it will come. So this is a coil where the turns are tightly packed. They are very closely spaced. This is a coil, and the magnetic effect, a magnetic field, will be n times the magnetic field produced by a single loop, right? So number of turns is n. N re gunibaku padibo. Acha, solenoid, you know, is a very typical kind of coil. It is a coil, but not all coils are solenoids. But solenoid is a very typical coil where the winding of the insulated wire is done in a helical manner like this, like a spring. So, and most importantly, ara lambei au tara mote, length to diameter, that ratio is very large. Now look to the length, ete chotto, diameter ata bahut bodo, kutha coil ro. Sadharana coil ro. But when you organize this coil in a very different manner like this, helical turn the gudeva over a particular medium, most of the time you can take air medium, or if you prepare a permanent magnet or temporary magnet, you have to take some magnetic materials, ferromagnetic materials inside. Otherwise it is air. तमे गोटे फांकारे करो, देन आराम रे ए जो छांचटाकू बाहर कर दियो, देखिबो से लागे कि रहिथिबो. सो द कोर इनसाइड विल बी एयर. ता भितरे एयर कोर हे पारिबो, ता भितरे कोन ना अन्य मटेरियल हे पारिबो, like iron and any other type of alnico, any other soft or hard materials हे पारिबो ता भितरे कोर्स. मजा जिंस होची solenoid एते लंबा compared to its diameter that ता भितरे field is uniform. Dota coil रे नहीं. But field is uniform. Of course, last बेल को ticket turn कर जिबो. Field is uniform. Last बेल को ticket turn कर जिबो. किंतु most of the distance it is uniform and doesn't depend on its distance from the axis of the solenoid. So that you can find out using this relationship where the field strength at any point, irrespective of its length, I mean its distance from the central point, any point, it is it is the same permeability into number of turns. N is the number of turns in the solenoid, and L is the length of the solenoid, and I is the current. Mu is the absolute permeability, and mu aguru kohichi mu ta kono na gote material kette efficient to be magnetized or efficient to carry the magnetic flux which are coming from north pole to south pole. More is the permeability, more is its power to be magnetized. So ethi mu not taku jodi ame 1 dhariba, tar value achi, it is 4 pi in 10 to the power negative 7 Henry per meter, but tar relative permeability dhara au kahara 500 800 ame usually 400 500 700 ei bhitere use koru for ferromagnetic material to be magnetized. So 8 house taro A. Mu is the absolute permeability, and if you know mu naught, which is this, and relative permeability kette guna adhika permeable, sei anusare tome bahar kari paribo, and field strength tome bahar kari paribo. And interestingly, you can know, since a solenoid is like a bar magnet, you can find the North Pole and South Pole, and those who have not studied earlier, as I have instructed you, because you are all uranium contestants, so they will be just little lagging behind because I'm going fast. Now, there are two ways to find out the North Pole and South Pole of a solenoid. One of the ways is which I like, is to apply the right hand rule. So once you apply, supposing the current is flowing in this direction of the solenoid, then the thumb, wherever it points, that terminal end is the North Pole and the opposite is South Pole. तमे गुटे नहीं जाइछो इतरे गुडा हिची तमे जानलो करंट रो डायरेक्शन टा एमिति जाउछ एमिति एपटु पळुछ तमे पॉजिटिव नेगेटिव जानिछो तेनु एमिति जाउछ सो तमे एमिति कलो हातटा याड जाउछ तो एटा हबो नॉर्थ पोल एटा साउथ पोल जदि एमिति गला ताले हातटा एमिति जाउछ ताले याड हात जाउछ एटा नॉर्थ पोल हबो एटा साउथ पोल हबो or the second way, which I think the physics professors they like more, is तमे चाहिबो गोटे एंड को आसिकरी चाहिबो गोटे एंड को आसिकरी चाहिबो जदी करंट रो डायरेक्शन ता तुमको एंटी क्लॉकवाइज आसला भलिया देखाउतबो सेटा हला नॉर्थ पोल ए नॉर्थ पोल को जदी एमती गोटे तीर चिन्ह देई दबो एन को लेटर एन को जदी गोटे तीर चिन्ह देई दबो ताले एटा देखा जिवो एंटी क्लॉकवाइज रो चिन्ह एमती सो एंड एटा जो तार ऑपोजिट ता होची साउथ पोल और जो एंड को आसिले तुमको देखा जिवो करंट ता क्लॉकवाइज जाउची एमिति so that is the south pole याकु जदी तार एंड रे जदी तीर चिन्ह देई दबो तो this is the direction of the clockwise rotation दक्षिणावर्ती that rotation घूर्णन and eta anti clockwise वामावर्ती घूर्णन. I am sure you guys are able to understand when I speak in English. So electromagnets already मु कहि सारिची एई जागा रे तमे जदी materials अन्य materials नबो if you take soft coarse annealed steel तबे temporary magnet हबो तुम temporary magnet चाहूचो अल्प समय पे रहिबो पुणी कि समय पर पळेबो ताहले एटा तम रिक्वायरमेंट अनुसार but तुम जो चाहूचो permanent synthetic or artificial magnet then you have to use chrome steel tungsten steel alnico rare earth magnets like neodymium iron boron or that is they are called neomagnets because it contains neodymium, samarium, cobalt magnets. There are so many materials which can be used as the core materials to convert into a permanent magnet. मजा जिनस होची कोन you kill two birds in one stone गोटे गोली रे दीटा शिकार कलो buy one get one free तमे एठी तो गोटे magnetic field पाइलो at the same time तो बाहर कर दलो से material को that became a permanent magnet. So you are supposing you are having some principle of motor or something like that where you use electromagnet or somewhere you are using electromagnet ठीक अछि करो किंतु कोरटा जदि तमे हार्ड नै जीव हार्ड मटेरियल नै जीव हार्ड माने टाण कथा मु कहूनी जोडा को तार परमेबिलिटी एमिति सुटेबल हबो जे से कि मैग्नेटाइज्ड परमानेंटली हे पारिबो से विषय रे अधिक जानकारी तुमको देबे डॉक्टर मिश्र. So this is the end of our second program, and we have the third program, last program. It's a force on a moving charge or current carrying conductor in a magnetic field. I guess raise your hands please. How are you feeling? How it is going? Is it going fast or you're able to catch it while I'm saying? Raise your hands, those who are with me through Zoom. It's going fine. Anil sir, he's a very respected and very talented teacher in Barampur, Vidya Mandira, Saraswati Vidya Mandira, Ramahari Nagar. He is watching remotely. So welcome, Anil sir. Keep on watching, and you also ask any doubt to Dr. Mishra on this particular topic that goes till the end of the principle of motor. Next time, next Sunday, we'll be having a program on the last part of electromagnetism, that is EMI, electromagnetic induction, and the principle of generator, both the DC and AC, right? Now, केमती जानिबा गुटे मैग्नेट परमानेंट मैग्नेट अछि मैग्नेटिक फील्ड से दउछि धर नॉर्थ पोल साउथ पोल आ गुटे जगह करंट जाउछि कि गुटे चार्ज मूव करूछि गुटे स्टैटिक चार्ज थला से डायनामिक हेकरी मूव करूछि से गुटे निश्चय इंटरेक्शन ऑफ द टू फील्ड बिकॉज़ a static charge when it is moving it is no longer static, it is almost like a current, so that will generate magnetic field. So also a current carrying conductor will also generate magnetic field. So गोटे मैग्नेट बुढ़ा मैग्नेट संगे आ गोटे कुनी मैग्नेट तो इंटरैक्ट करिवे तर मैग्नेटिक लाइंस ऑफ इंडक्शन जते दे विल इंटरैक्ट विथ ईच अदर, दे विल इंटरफियर, देन कोटी कटाकटी हे जिवे कोटी बढ़ी जिवो कोटी कमी जिवो, सो दैट अकॉर्डिंगली ए फोर्स whether repulsive force हो कि attractive force हो जहाँ हो, it will be experienced by the current carrying conductor or moving charge. And to know the direction of that particular force that the current carrying conductor experiences, you can use the Fleming's left hand rule, FLH. So to avoid confusion, I will tell you two things. Many physics teachers have learned from Dr. Mishra, and I'm sorry that I have borrowed this from you, and with your magnanimity and generosity, you will bear with me that I am using your term that I have learned from you, that right hand thappad rule. So many physics teachers, they simplify only to the right hand, which is a better hand. Left hand is not a good hand. We do many nasty things. Oh, I'm sorry. Some of you might be lefties. No, I'm so sorry. And so every hand is good. Just in a very lighter note, lighter vein, I'm saying. So they make use of only right hand and make the rules, they sometimes change the rule. I also agree to that. It is more, useful than you taking your left hand and you will face much more difficulty than using a right hand thappad rule. I will explain to that. First, let us honor the Fleming who developed this rule that jodi field direction eta dekho ame taktu padichu ei jinso. There are many other things letters which represent the three terms. One is the magnetic field direction, the other one is the current direction, and the other one is the thumb direction. So for me mate eta bhal lage thumb m ta ku nei, m stands for motion, the same manu tu musikichi, and first finger eta f nei field, and middle or mojita I ta ne mojino I ta ku nei as current. So m f I mo pai eta current, that will be indicated by the middle finger, this one, and forefinger or first finger will represent the field, and this motion जो direction रे force काम करिवो, and BC अंगूठी tomorrow होबो first finger, it will be होबो field direction, and बुढ़ा अंगूठी, I mean middle finger, will represent the current direction. Then only you can get बुढ़ा will be the requirement. आमे बुढ़ा को खोजुचे ए दीटा हमर जानिचे बुढ़ा को direction होबो जणा पड़िबो हेले. Now see, you can tell me that जदि current रे direction हला एटा, देखो मु केते हाथ कष्ट करियो पड़ियो, current रे direction हला एटा, and मोर नै एम्ति करियो पड़ियो, एटा नॉर्थ थ्रू साउथ डायरेक्शन होची फील्ड डायरेक्शन एटा बीसी अंगूठी आई मीन एट द फोर फिंगर एंड करंट डायरेक्शन होची एटा एमिति बाबा हाथ काटिलानी 90 डिग्री से परस्पर 90 डिग्री रहिबे दे आर परपेंडिकुलर टू ईच अदर तो अंगूठी परपेंडिकुलर रहिला बेलको मोर बहुत एटी ये होची सो सो एटा हला करंट डायरेक्शन एटा हला फील्ड डायरेक्शन तळु ऊपर को नॉर्थ पोल साउथ पोल को एंड एटा विल बी द डायरेक्शन ऑफ the motion or the force. That means it will go out of this magnet, it will go to the right, and the ulta current jibo tale bhitor ko jibo obviously, right? Kintu dekho right hand thapod rule, how it is easy to understand. Right hand which we have learned, the right hand, well, right hand slapping rule bahare to आमर सिना थापड़ चढ़ो आई डोंट नो वेदर इट इज ए हिंदी टर्म नहीं हिंदी रे थापड़ को कहती एनीबॉडी हु कैन राइट मी इन द चैट बॉक्स हिंदी रे थापड़ को कौन कहती कहलो कौन एक बढ़िया टर्म अछि मो
हिंदी में आल्सो इज थापड़
ना मो हिंदी रे थापड़ ना आ गुटे कोन
यस 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 हिंदी में भी थप्पड़
ओके ओके थैंक यू डॉक्टर मिश्रा से देखो थापड़ रूल टा केमती एमाने सब बाहर करिसंती सब टीचर माने मो एते सिंपलीफाई करिसंती जदी तुमे तुमरो पाम टाको सीधा रखिबो एमती एक्सेप्टिंग बुढ़ा अंगूठी पाम टाको सीधा रखिबो बुढ़ा अंगूठी 90 डिग्री रे थिबो एमती एंड दैट ऑल द डायरेक्शन ऑफ द पाम रो पापुली रो सब अंगूठी जो सीधा अछि सेटा डायरेक्शन का कुआडे जीवो ना फील्ड रो डायरेक्शन जीवो तले बुढ़ा अंगूठी देखिबो एंड तुमे कोन करिवो जो पटे पापुली अछि तार फ्रंट को तुमे मारिबो गोटे लोक को चापड़ा एमथि धरो इठी ठिया हिची आरत्रिका हमरो यूरेनियम पिला ताको मु गोटे एमथि मारली ता गालटा इठी अछि ढा करंट डायरेक्शन एटा हमें करंट डायरेक्शन तो इठी चेंज करले बिली लेफ्ट को राइट कर देले करंट डायरेक्शन ता बुढ़ा जोटा हितला कोन मझी मिडिल फिंगर जोटा हितला एवं एटा ए डायरेक्शन ता होची कोन ना फील्ड डायरेक्शन ता एटा होची करंट डायरेक्शन ता तबे तुम जदी थप्पड़ मारिबो ए सीधा रे पापुली रो सीधा रे जो डायरेक्शन रे जीवो सेटा हला the motion, I mean the direction of the force that is exerted by the magnetic field. ना सही जिनसे चला अप्लाई करिया देखियो कोटा तुमको भल लागुची. Those who are new to this, not studied, despite my request, they will experience. देखो तमे मु आउ लेफ्ट हैंड को यूज करूनी, राइट हैंड यूज करूची. So field direction एटा नॉर्थ थ्रू साउथ एटा आउ करंट डायरेक्शन एटा मत नबा पड़ी बर्तन बुढ़ा अंगूठी करंट हो गलानी तो बर्तन मो आगरे अछि कि जी अछि ताको मारली आरत्रिका अछि. सो यार्ड को जाउची हाथ ता माने डेफिनेटली फोर्स पड़िबो राइट हैंड साइड को. सो यू कैन यूज देम. एठी गोटे तुमको देइची यू कैन डू दैट. इट गोटे मैग्नेटिक फील्ड जाइची तळु ऊपर को जाइची बी रो डायरेक्शन ता एठी सर्किट जदी क्लोज कर देले गोटे आयरन रॉड नेले इट सर्किट क्लोज कर देले डायरेक्शन ऑफ द करंट या हला ताहले को पट को जीवो एई रॉड लेफ्ट को जीवो कि राइट को जीवो कहलो देखिबा. अनिल सर पढ़ांती अनिल सर ताको पढ़ांती आमे जो राइट हैंड थापड़ सिखितले डॉक्टर मिश्र टू अनिल सर तांको तांकर गोटे नुआ रूल बाहर करते तथास्तु रूल. तथास्तु कहीं गोटे थापड़ दबो दो दो 17 जदि बाजी जीव ताल बापा केस कर दबो आरत्रिकार बापा मते ये करिवो कोन सु करिवो हाईकोर्ट रे मु जीबी जेल चकी पिशिंग एंड पिशिंग. तेणु बेटर हबो आई एक्सेप्ट तथास्तु रूल. रादर तमे स्टूडेंट को तमे ये करिवो ब्लेस करिवो तथास्तु करिता मुंड पंत नबत तथास्तु बाडेइबोनी तथास्तु. राइट हैंड रे तथास्तु. लेफ्ट हैंड तो फ्लेमिंग करिसंती फॉर द फोर्स ऑफ सो तुमे करि परिबो की कहि परिबो ए केस रे ए रॉड ता राइट को मूव करिवो कि लेफ्ट को मूव करिवो. रेज योर हैंड्स एंड पिक अप. बी कॉम्पिटिटिव जे ओपन करी कहबो से ही हबो मुकद्दर का सिकंदर.
Sir, right. Right.
Right.
ଡାହାଣ ପଟକୁ
Right कहउचंती ओम साई प्रीतम.
आगे sir ମୁଁ ବି right କହୁଛି.
अच्छा आरत्रिका
ଡାହାଣ पटକୁ राइट साइड
राइट साइड को. ओके जदी करंट रो डायरेक्शन टा याडे हैला पॉजिटिव रु नेगेटिव को एटा हैला ताहले आमे बुढ़ा अंगुठी सियाड देले थापड़ मारी हम ए थापड़ कहउची तथास्तु करूची. नर ऊपर को जीव ऊपर तो के नाहंती काहा को तथास्तु करवा. आरत्रिका को क्या करियो एमिति सरे तथास्तु. आई एम जस्ट kidding Anil sir. You have a very great term तथास्तु. ना आमे तथास्तु चालू करवा. करंट फील्ड रो डायरेक्शन होची एमिति एमिति एंड करंट डायरेक्शन होची एमिति तो बोले तापर तथास्तु करियो जा हो एपट एपट करछ ना अछि अरे तथास्तु. So it will come to the right. So that is very easy, I thank salute the guys. मु जेतले पढुथली सेतले मु मते मो टीचर केवल लेफ्ट हैंड राइट हैंड सिखैथिले. लेफ्ट हैंड फॉर दिस प्रिंसिपल ऑफ मोटर, that is the force, and EMI पई राइट हैंड. ए जिंस मु जानिली ए मान टू. So it will move. Force empty exactly force exerted on a moving charge. Gote charge q. It's not a current in a conductor, but same. Gote charge ta jodi move kala, that is as good as a current. So same apply kariba. And I forgot to tell you, yes, let me tell you. Say ekka principle apply kariba. We have already known that the principle of why it gets a force. You can understand the current carrying conductor circular lines of field lines and 8 straight lines. So north to south pole jauchi ebong e dita ka misi jauchanti same direction. So the field strength is increasing at one part in the upper part, and they are cancelling each other to a large extent. So the field strength is decreasing on the lower part. So the conductor will experience a force from a higher field strength to a lower field strength. It will come down. So that is the way you understand how and why a force is exerted on a current carrying conductor or a moving charge by the presence of an external magnetic field. And to know the quantity of force and its direction, आज गोटे इंटरेस्टिंग कथा तुमको कहबी. There are 3 ways. One way हला लेफ्ट हैंड रूल ओरिजिनल. एटा हला तथास्तु रूल बा थाप्पड़ रूल. ए सॉरी थाप्पड़ रूल. आ गोटे तुमको रूल आज कहबी सेटा होची वेक्टर प्रोडक्ट मेथड रे केमति बाहर करि परिबो. Once you understand, you can do it. Now actually unlike flux, which is a dot product or scalar product, the force is a vector product or a cross product between these two vectors. One is called the I current, which is not a vector quantity, but when it is multiplied with a length vector the area vector thila, तार direction टा किंतु perpendicular थिला. The length vector direction is same as the direction of current, but हमको गोटे length vector नबाक पड़िबो because current is a scalar quantity. So this IL vector and the B vector. Ago IL, tapore B. Remember, ago IL then B, not the other one. So the negative direction alga hijiba. Ago IL vector cross B. Taro magnitude habo A. Supposing there are 2 vectors A and B. तार क्रॉस प्रोडक्ट हबो एटा तार जेमति हेतला AB cos theta एटा हबो AB sin theta. So IL into B sin theta. Theta is the angle between the B vector and the length vector, right? Theta is 90 degree to perpendicular direction re achi theta the curve, the current and the field, then sin 90 will be 0. So this will be simply ILB. Now to know the direction of the product hala force, and unlike the dot product of 2 vectors, the product is a scalar quantity. Sethipai taku scalar product कहंती. किंतु cross product is a vector quantity. ता direction मध्ये अछि. से भी right hand. तमे प्रथम vector द्वितीय vector को तमरो अन्य आंगुठी को curling करियो. All other fingers will be curled in the direction from A to B. First vector, second vector karibo, and thumb will represent the direction of the product. In this case we have the L vector, that means the current is not a vector, IL vector. सेटा को रखिबा आग ताकू आग हाथ रखिबा माने से डायरेक्शन रे देन हाथ को बुलेइबा बी वेक्टर देन बी द थंब जुआडे नबो एमिति की जुआडे जीवो कि एमिति जुआडे जीवो दैट इज द डायरेक्शन ऑफ द फोर्स बिकॉज़ फोर्स is a vector quantity which is obtained by the scalar product of two vectors. Now let us apply, before I conclude, I apply this rule. I mean, treating as two vectors, taking the vectors of vector product or this cross product. Let us understand how to know the direction of force. Say for example, आमे कौन करिबा ना हमर अन्य अंगुठी गुडाक रखिबा I डायरेक्शन रे एठी आ ये न जिबा नै एटा हला I रिमेंबर मु केते चेंज करूची मु सम अप करिबी एटा हला I वेक्टर माने करंट वेक्टर करंट वेक्टर नुहे किंतु L संगरे गुणा हे गेले सेटा उडा वेक्टर हे गेला सो IL वेक्टर टा एटा करंट सेठी जो थापट रूल करथिले तथास्तु रूल एटा को फील्ड डायरेक्शन करथिले बर्तन एटा को करले कोन वेक्टर अनुसार करले ना एटा होची IL वेक्टर एंड ता आगो सेठू ता पर वेक्टर को जिबा IL प्रथमे लिखा आइछि तापर B लिखा आइछि B होची एमिति गले हमर बुढा अंगुठी जाउछि कुआडे ना डाहाण को सो इट विल मूव टू द राइट कोटा भल लागिला क्रॉस प्रोडक्ट अनुसार ना तथास्तु और थापट रूल अनुसार और द ओरिजिनल फ्लेमिंग्स लेफ्ट हैंड रूल कोटा भल लागिला रेज योर हैंड्स ओम साई कोटा भल लागिला
थापट रूल
I also expected that आउ कहा को क्रॉस प्रोडक्ट भल लागिला सब चेंज करिया पड़ियो इन लेफ्ट हैंड रूल द मिडल फिंगर वाज करंट and this was the force eta field in I'm sorry तथास्तु rule this all eta सीधा रहिबो सीधा ए डायरेक्शन ता हो field एटा करंट देन थापड़ जो डायरेक्शन रे जीवो बा तथास्तु जो पटे जीवो एमिति सेटा हला डायरेक्शन ऑफ मोशन एंड एठी क्रॉस प्रोडक्ट अनुसार तुमे आगो IL क्रॉस B आगो I डायरेक्शन रु कर्ल करिवो B डायरेक्शन रे फील्ड डायरेक्शन रे तेबे तमरो बुढा अंगुठी जुआडी जीवो सेटा होची फोर्स रो डायरेक्शन सो चार्ज कथा भी सेही जिंस चार्ज जिंस भी सेही जिंस किछि डिफरेंस नाही एंगल जदी अन्य कोन थिबो से अनुसार sin 60 हे जीवो sin 35 हे जीवो सो प्रॉब्लम सो पचारिचो सो चार्ज केवल डिफरेंस होची कोन सेठी यू नो I was a scalar quantity its velocity will be the vector quantity so q is the magnitude of the charge moving charge and v is its velocity so seti IL jagare qv he jibo into b is also a vector quantity so ultimately qvb sin theta same and you can know this is very interesting. Pritam had asked me a question to calculate what will be the magnetic flux when the currents are opposite, currents are same direction. It is same direction regularly attraction hobo dita current carrying conductor with attraction hobo and the opposite direction is your repulsion hobo. So to remember we can say SA sa and this is OR Odisha so opposite repulsion hobo you can understand why attraction hochi कारण एटा एमती जाउची बा पटटा एमती जाउची तार डायरेक्शन ता एमिति एटा तळकु जाउची ए सेटा भी ऊपर को जाउची डायरेक्शन ता एमिति सो दीटा तक फील्ड मिशी जाई करी ए सॉरी दीटा को फोर कैंसिल कर दे करी एपोटे हे जाउची रैरिफैक्शन एटा माने बहुत कमी जाउची मैग्नेटिक फील्ड बाहर से माने मिसुचंती मिसला फल रे से मानकर फील्ड स्ट्रेंथ बढ़ी जाउची बाहर so definitely a force between the two straight carry conductor will be experienced inwards कहना तुम निजे देखिबो applying the screw rule or the Maxwell rule देखिबो एटा जाउची एमिति एटा आउट पर अछि डॉट अछि माने आउट अछि एमिति एटा इन जाइछि एमिति so मझी पटटा दे कटाकटी each other मझी पटटा दे कटाकटी each other and they become less magnetic strength becomes rarer and bahar patota they add up so the magnetic intensity or magnetic field becomes greater outside and rarer lesser inside so there is an attraction if they are an opposite they're in the same direction So no, this is opposite direction. There is repulsion. I'm so sorry. This will be same. I'm so sorry. I'm withdrawing. I'm withdrawing. So this is going out. So एमती बुली राइट हैंड एटा सेम डायरेक्शन एटा तळकु जाउची एमती बुली करी एमती आसला को सेम डायरेक्शन रहि जाउची सो भितरे अपोजिट साइड रे गले एटार फोटो माने मु कोन कली ना टिके ये हे गली सो एटा अपोजिट क्रॉस एंड डॉट सो क्रॉस एंड डॉट हेले भीतर पटटा स्ट्रांग हे जिवो बाहर पटटा वीक हे जिवो जोटा मु करिनी ड्रॉ करिनी ऑटोमेटिकली एटा स्ट्रांग हे जाई देखा जाउची एटा रेयर हे जाउची सो देयर विल बी रिपल्सन ऑन द अदर हैंड यदि अपोजिट जीवो ताहले भीतर पटटा अपोजिट आसीबो दे विल कैंसल ईच अदर सो भीतर पटटा वीक हे जिवो बाहर पटटा स्ट्रांग हे जिवो सो इट अट्रैक्शन हो सो रिमेंबर that when the currents are in the same direction there will be attraction because eta mu thik jaga re alignment karini bili same direction there will be attraction bhitor patota kam he jibo and whenever there will be opposite direction bhitor patota strong he jibo bahar ta weak he jibo so there is repulsion from stronger field to weaker field repulsion so that comes to the end of our program and let me quickly tell you why Earth is considered as a bar magnet because just like a bar magnet it has a north pole and in the opposite side there is the opposite pole so just like that they have geophysicists have found out the north pole in near to the geographic north pole I mean the south pole near to the geographic north pole and the north pole nearer to the geographic north pole सेति पई गोटे इमेजिन हमें करू एज ए बार मैग्नेट आयरन मु ऑलरेडी कहि सारिची आयरन गोटे फेरोमैग्नेटिक मटेरियल एंड सेटा को टाणीबा पई जो स्ट्रेंथ दरकार अर्थ रो सेति की स्ट्रेंथ नाही सो मोस्टली प्रिडोमिनेंटली ड्यू टू ग्रेविटेशनल फोर्स इट फॉल्स डाउन यू कैन करेक्ट मी आई एम एमेनेबल टू एनी मॉडिफिकेशन बाय दैट आई विल लर्न थिंग्स एंड देन we have some problems you know we mate kahithila se eta 12 number page re achi eta mu calculation kari deichi so the principle se pacharchi gote 10 ampere current gote jauchi infinitely long where jauchi a gote pakhre gote element achi gote conductor element achi se 20 ampere opposite direction re jauchi एवं डिस्टेंस ताको भितर 10 सेंटीमीटर एवं यार लेंथ हो 20 सेंटीमीटर तबे व्हाट इज द आई मीन व्हाट इज द फोर्स दैट इट विल एक्सपीरियंस फोर्स जानिया पे हेले प्रथमे आगो फील्ड स्ट्रेंथ जानिया पड़ियो बी ए फार्मूलाटा मु देइची ताको यूज करि करि जानलो देन ILB sin IL क्रॉस B बा ILB sin 90 बिकॉज़ इटा फील्ड जो प्रोड्यूस करिवो सेटा फील्ड डायरेक्शन आउ करंट डायरेक्शन 90 डिग्री परपेंडिकुलर अछि सो एटा को हमें 1 नै जिबा सो ILB गुणी देली सो एतिकी न्यूटन रो फोर्स पड़िबो इठी ने परपेंडिकुलर डायरेक्शन रे आ गोटे क्वेश्चन इज वेरी सिंपल जे एटा गोटे अछि क्रॉस माने इनटू फील्ड जाईची भितर को एवं एटा गोटे कंडक्टिंग वायर 20 एम्पियर जाउची 30 सेंटीमीटर तार दैर्घ्य এবং সে পচারছি হোয়াট ইজ দি ফ্লাক্স নাই তার মাসটা কেতে হেলে তার বস্তুত্ব কেতে হেলে সে আউ তळକୁ জীবনি কি উপরକୁ জীবনি তা মানে গ্র্যাভিটেশনাল जो পুল তা সঙ্গে ইকুয়ালাইজ হে যিব সো ইট উইল রিমেইন ইন ইকুইলিব্রিয়াম ইন অ্যানিমেটেড সাসপেনশন সো ILB 90 डिग्री अछि बोली sin 90 नेली ILB को mg संगे इक्वेट कली तो सेइथरु मास देइछि से केजी रे प्रकाश कली and acceleration due to gravity देइछि I देइछि and length देइछि ताको सबु SI यूनिट को आनी कि फाइनली मोर भारला 166.7 गाउस और 16.67 मिली टेस्ला सेमती मध्य करिछि तुमे बाहर करिवो जे एटा गोटे इनटू जाइछि एटा आउट जाइछि दीटा current carrying conductor तार भिन्न भिन्न पॉइंट रे बाहर करिवा को करिछि मु करि देइछि you can see I will send you it's not a big deal and a gotaka more answer missilani. So I requested, somewhere I am doing the mistake. I will discuss with Dr. Mishra but this is a simple one. I think where I'm going wrong, Dr. Mishra will point me out. This is a circular current carrying conductor, and this is also a circular carrying conductor. In opposite direction current is flowing, and the diameters are different, and the flux density has a different formula, mu naught I by 2r radius. Say formula jehetu opposite direction रे अछि मु माइनस कर देली. So ultimately number of turns are 300 टा 500 टा number of turns रे गुणिली finally more बाहरला answer एतिकी 1.1 pi millitesla. Kintu answer is something different, so he will tell me. So thus I come to the close, although I took little more, doesn't matter. I mean, 1.5 घंटा पर्यंत program करिवा. So I'm sure the guys who are watching are in the same spirit as. Now I invite Dr. Mishra to show his appearance before the public to make his video on. Any question?
Thank you very much, Dr. Tripathy. You explained the magnetism and electromagnetism very elaborately and also very lucidly. पिला माने निश्चित भाव में आपण क्लास अटेंड करथिबे आ भलो भाव में बुझी पारथि बोली भाबुची आ बेसिक जिंस गुडा पिलांकर जो थिला प्रथमे ई प्रॉब्लम न्यूमेरिकल कथाटा म कहि दिए आपण जो न्यूमेरिकल टा सॉल्व करछि इट इज 100% करेक्ट the answer is also your answer is correct what I think it is 110 into 10 to the minus 5 Tesla or 1.1 into 10 to the minus 3 millitesla as you have done. I don't think there would be any other answer.
Hello, Dr. Mishra, please repeat because there was a lag. There was internet lag. Please repeat what you said.
Whatever you have calculated, actually the currents are in the opposite direction. So the magnetic fields will be in opposite direction. So they will be subtracted. Usually the smaller coil has more magnetic field at the center.
Yes.
Of course, that depends upon number of turns also. Yes. This also you have done correctly. This is correct. 6,000 minus 500. This is correct. This one is this is an additional zero you have taken, I think. This is 110 into 10 to the power minus 5. This pi
pi ta rahichi, pi I have not deleted. How it kon kali 4 re gunili 11000 he gala. 11000 pi 10 to the power negative 7. तो मु kon kali ना एटा को 4टा decimal place को shift kale 10 to the power 4 re guni.
This is mu 0 is 4 pi into the minus 7. So these two will cancel out, na? This 2 is there.
How to say 2 pi na nahi na se formula re tole pi nahi.
No, tole pi nahi. Mu 0 is 4 pi into 10 to the power minus 7. Correct. Mu 0 4 pi into the minus 7. And this is coming as 5,500. 2 you have cancelled here. Acha. Okay.
mu kon karichi.
ठीक है. So this is coming as 5,500 into 2. This 4 pi. This is 4 pi.
11,000 he gala.
4 pi. No, 2. You simply got it here. 4 by 2 is 2.
Yeah.
So 2 into 5,500.
Yes.
2 into 5,500. It is 11,000. Correct. Pi. It is correct. It is 100% correct. 10 to the power minus 7. This is 1, 2, 3, 4. 1, 2, 3, 4. So this is minus 3. So this is 1.1 into 10 to the power minus 3. It's correct.
And please tell me this one at this point Q. मुकिची भूल कर ता संगरे मिशिलानी. देखो guys, एठी तुमको direction देइची. Those who do not know about the unit vector concept, तुमे जानिबो class 11 रे जानिबो. So A point रे जेहेतु एटा opposite direction रे अछि तेणु एठी ऑपोजिट रिपल्सन हबो तेणु रिपल्सन हबो एवं ए डायरेक्शन टा एमती
Not
same
repulsion.
direction as
Actually, one thing I want to point out here, actually these cross and dot symbols, usually they are denoted for magnetic field, not for direction of current. Usually. No wrong way. Nabar kichhi asubidha nahi. Kintu magnetic field pai eta denote kara jay. Dot means the magnetic field is outward from the plane of the paper or plane of the screen, and cross means magnetic field is into the plane of paper or into the plane of the screen. This is not denoted for current actually. So this symbol should be always used for magnetic field, not current.
Okay. So this is as added to my knowledge that आमे किंतु मु बही मान करे देखि छी मु current रे plus minus लेखु चंदे cross और dot लेखु चंदी, which is wrong.
That's a convention. That's a convention. But actually this is denoted for only magnetic field.
More valid for magnetic field.
That is for magnetic field.
Okay. Now एटा देखो पिला माने एठी the direction टा downwards अछि, negative y axis. तेणु गोटे जेतेबेले तमे दबो ता डायरेक्शन देखैबो गोटे नेगेटिव y रो डायरेक्शन होची j cap.
Suppose this one, this is going into this is going into, suppose current direction, this one. This is going into. Okay?
Yes.
So you apply the this direction, the current is moving into this one.
Yes. So
this
center, it will be coming downwards, the direction will be downwards, so that the direction you will show with a negative y-axis, and this is the unit vector in the y-axis, negative y-axis, it may minus j cap diala. Okay. How sobu answer more thik asila in this point, this will be 5 and a point ru eta 5 5 10 5 15 8 hote ko 15 8 hote ko 5. And then I have subtracted because they are going in opposite direction. They have subtracted because 80 same direction re asuchi, seti pai repulsion hochi. So seti pai mu subtract karichi, mor baharla answer thik. And
you are calculating, sorry to interrupt, you are calculating the magnetic field due to this conductor and this conductor. You have to calculate it individually. Suppose at P point, find out the magnetic field of this conductor. Here mu0 I by 2 pi d.
And by this conductor,
find the direction, and then for this conductor you find the field at here 15 meter or centimeter, whatever it may be. This is 15 unit mu0 I, this current, divided by 2 pi 15.
अलगा अलगा करी करी अलगा अलगा डायरेक्शन दे करी फाइनली वेक्टर एडिशन करिया कथा.
Yes. Not attraction or repulsion.
मु शॉर्टकट रे कर दिली, मु जानिली ए रे जो जाउची सेटा अपवर्ड्स जाउची एमिति एंड बी रे डाउनवर्ड्स जाउची. तेणु अपवर्ड्स ता अधिका, हेठी 5 अछि तळे 5 आसीबो, एटा 15. तेणु करी अपवर्ड्स y एक्सिस रे पॉजिटिव y एक्सिस रे रिजल्टेंट आसीबो. तेणु ए कैप टा प्लस आसिला, जे कैप सेठी माइनस आसिला, एठी प्लस आसिला. एंड सेम विल बी द केस हियर. एटा 5 सेटा 15, एटा मध्ये अपवर्ड आसीबो देखिबो. किंतु मोर आंसर मिसिलानी, कोठी मु भूल अछि कि नाही. आई वांट टू लर्न
मैग्नीट्यूड और डायरेक्शन.
हां, क्यू पॉइंट रे मु कोन कली डॉक्टर मिश्रा, एटा 5 देछि, एटा 5√2, एटा 5 एटा 5√2. सो ए पॉइंट रे से माने अपोजिट डायरेक्शन रे जाउचंती, ए सेम डायरेक्शन रे जाउचंती, ऐड हबो. तण मु तले कली सेते बेले मोर बाहरिला एया, किंतु आंसर देछि 2, √2 ता तार नाही, मिसिंग. तो एटा तो डेफिनेटली परपेंडिकुलर, करंट कैरिंग कंडक्टर एटा परपेंडिकुलर अछि, जो डायरेक्शन इनफाइनाइटली जहाले भी परपेंडिकुलर हबो. तो सेही अनुसार मु बाहर कली, एटा बाहर कली. सो ए पर्टिकुलरली क्यू पॉइंट रे कोन भूल हैला एंड ऐड कर देली. If my concept is correct, then the answer might be wrong, but I've seen 2 to 3 times. I've seen.
No, it is correct. The distance is 5√2, na? So distance is 5√2.
मो पाखरे आंसर टा इठी देइची प्रीतम मु इठी देखि दोची तार आंसर टा केते नंबर एटा ए पी क्यू आर एस एठी अछि एठी कोड हां एठी बी क्यू टा होची -2 माइक्रो टेस्ला -2 माइक्रो टेस्ला सब ठीक अछि किंतु ए √2 टा तार बोधे मिसिंग करछि मते लागुछि नै
हां मिसिंग √2 मिसिंग
Okay, that's all. Any question? Raise your hands. Yes, Om Sai. Aratrika, first Aratrika. Ladies first.
Sir, why I is not a vector when I is flow of electron?
कौन I?
हाँ, current.
हाँ, क्या? Vector नुहे.
हाँ.
हाँ.
कंपेन
हमें कौन पाई ताकू वेक्टर प्रोडक्ट करूचे है तो IL क्रॉस भी है.
आज्ञा.
हाँ, डॉक्टर मिश्रा.
हाँ, ता आंसर तार क्वेश्चन टा अलगा अछि. तार क्वेश्चन होची करंट तो डायरेक्शन अछि. ताले सेटा वेक्टर काई कि नुहे. या तो आरत्रिका.
अच्छा, कालो ठारो कालो मा जाने.
नहीं कि आरत्रिका.
आज्ञा.
से कुछ करंट रो डायरेक्शन अछि वेक्टर काई कि नुहे. सेंति आउ किछि मु तुमको एग्जांपल दोची टाइम रो मध्ये डायरेक्शन अछि. इट फ्लोज फ्रॉम पास्ट टू प्रेजेंट टू फ्यूचर. नहीं कि पास्ट टू आसीबो प्रेजेंट को जीवो फ्यूचर को जीवो. तो टाइम इज आल्सो ए स्केलर क्वांटिटी. आउ किछि आजि पढिलो जंती मैग्नेटिक फ्लक्स जो फील्ड लाइंस तार भी डायरेक्शन अछि. से नॉर्थ टू साउथ हरी जाउची. स्टिल देन मैग्नेटिक फ्लक्स जोटा सेटा होची स्केलर क्वांटिटी. सो एमती किछि क्वांटिटी अछि जार डायरेक्शन अछि सी किंतु स्केलर क्वांटिटी. प्रथमे तो बुझिया पड़िबो स्केलर और वेक्टर भितर कोन डिफरेंस. बेसिक डिफरेंस कोन. स्केलर तो मैं जानि छ जार केवल मैग्नीट्यूड अछि. मैग्नीट्यूड अछि माने मैग्नीट्यूड द्वारा हमें ताको रिप्रेजेंट करि पारिबा. आउ दिग जार मास जेंती जो दिगरु बाहर कर मास र वैल्यू सेम आसीबो. तो मास इज स्केलर क्वांटिटी. तो वेक्टर क्वांटिटी माने कोन ना जो क्वांटिटी को रिप्रेजेंट करिया पई जो फिजिकल क्वांटिटी को रिप्रेजेंट करिया पई दुईटा जिंस दरकार. गोटे मैग्नीट्यूड दरकार आ दिग दरकार. जदि ता भीतर गोटे तमे कहून ता विषय तमे सविशेष तथ्य पाउनी. यू आर नॉट एक्सप्लेनिंग इट प्रॉपर्ली. जेंती तमे कहूछ तम घरु तम स्कूल र दूरता माने कर 2 किलोमीटर. तारे तमे जदि तम घर 2 किलोमीटर बाट चलीबो जे कोन से दिगरे चले स्कूल ले पहुंचीबो कि नाही. तमे हो त जाईगिरी तम सांग डायरेक्शन घर जाई पहुंची जीवनी स्कूल बदले. तमको स्कूल टा यदि तम घर नॉर्थ आड़ी की अछि तमे नॉर्थ आड़ी की 2 किलोमीटर गले ठीक स्कूल ले पहुंचीबो. बर्तन क्वेश्चन होची स्कूल रो तम घर रो दूरता केते. ता 2 किलोमीटर. ताले स्कूल रो तम घर को आसिया पई तमको एक्जेक्टली साउथ डायरेक्शन में आसिया पड़िबो 2 किलोमीटर. ताले 2 किलोमीटर मैग्नीट्यूड आउ नॉर्थ के पास साउथ डायरेक्शन मेंशन करले ताले तमे घर स्कूल को किबा स्कूल घर को पहुंच पाछो. तो दिगटा होची इंपोर्टेंट. तो सेही भलिया क्वांटिटी को हमें कहले वेक्टर क्वांटिटी. एठी एई एग्जांपल ले होची एटा होची डिस्प्लेसमेंट. गोटेला डिस्टेंस आउटेला डिस्प्लेसमेंट. तो डिस्प्लेसमेंट वेक्टर. ता माने जो क्वांटिटी को रिप्रेजेंट करिया पई दिग आउ मैग्नीट्यूड दीटा को दरकार होची सेटा हला वेक्टर क्वांटिटी. द रिवर्स इज नॉट ऑलवेज ट्रू. माने जहार दिग आउ मैग्नीट्यूड अछि से जे वेक्टर हबो सेमिति किछि माने नाही. भले करी बुझ. जो क्वांटिटी को रिप्रेजेंट करिया पई मैग्नीट्यूड डायरेक्शन दरकार सी हबो वेक्टर. ओलटेटा सबले ठीक नुहे. जहार मैग्नीट्यूड डायरेक्शन छी से निश्चित भाबरे वेक्टर हबो सेमिति नुहे. जदि गाई रो चारिटा गोड़ जहार चारटा गोड़ से गाई की गाई रो चारटा गोड़ जहार चारटा गोड़ से गाई की. तो जहार ना तो जहार मैग्नीट्यूड डायरेक्शन अछि से जे निश्चित वेक्टर हबो सेमिति नुहे. ताले एठी कोन होची ना जो वेक्टर जदि हेतिबो तार नेगेटिव वेक्टर मध्ये पॉसिबल. माने जदि नॉर्थ रु साउथ जाई पारुची ताले साउथ रु नॉर्थ मध्ये दिग हेई पारिबो. किंतु तमे दे टाइम नउचे टाइम टा जाउची प्रेजेंट रु फ्यूचर को केबा पास्ट रु प्रेजेंट को रिवर्स रे जाई परिबो की अलत्रिका जाई परिबोनी तो टाइम टा वेक्टर क्वांटिटी हे पारि किबा ताकू जतरे आमे एडिशन करूचे मिसौचे 5 सेकंड युक्त 3 सेकंड सब बेले 8 सेकंड किंतु वेक्टर क्वांटिटी रे 5 युक्त 3 8 हे पारे 5 युक्त 3 2 भी हे पारे तमे बसिछ तम बेणी को जणे तम भाई गोटे नॉर्थ को टाणिबो आ तम आ गोटे भाई साउथ को टाणिबो 5 न्यूटन तमे कोआडी जीवो
स्थिर
स्थिर रहिबो 5 युक्त 5 केते हला
Okay, let us go to the next question. I think.
शून्य हो गला तेणु माने सेठी 5 माइनस है तेणु नेगेटिव वेक्टर ठीक है तो जोठी नेगेटिव आसीबो नेगेटिव डायरेक्शन ही परिबो सेटा ही वेक्टर तेणु ए केस तो करंट मध्ये से इट फ्लोज फ्रॉम पॉजिटिव टर्मिनल टू नेगेटिव टर्मिनल दैट्स व्हाई इट इज स्केलर ऑल द डायरेक्शन ही परिबो ना सो इट्स ए स्केलर क्वांटिटी
And maybe, Dr. Mishra, maybe the addition principle, the vector addition principle, it is not conforming. The current electricity रे आमे देखिबा जे जदि ताकू वेक्टर क्वांटिटी नबा वेक्टर एडिशन रो जो नियम अछि कंपोनेंट मेथड ये मेथड से मेथड सेटा को से फॉलो करू नै
यस
सेति पई डॉक्टर मिश्र कहिले द रिवर्स माइट नॉट बी ट्रू so positive to negative the current direction that is a fictitious I mean conventional one actually electron is flowing in the opposite direction but even then we have made the rules positive to negative jauchi seti pai
I want to add something that is what I was explaining about the addition principle vector principle 5 युक्त 5 शून्य होची 5 युक्त 3 2 होची 8 भी होची vector principle सेटा direction method even you are considering the direction of flow of electron that is flowing in one direction there are reverse direction possible when you are considering the direction of flow of current it flows from positive to negative reverse is not possible so whatever if the reverse is not possible that is one point the second point is vector addition and vector rules all these are not applied.
No, I beg to differ, Dr. Mishra. that the reverse is possible.
Yes, just point me out that.
किंतु आमे ताको जबरदस्ती धरिछु पॉजिटिव और नेगेटिव टा करंट फ्लो करछि बाय कन्वेंशन
नहीं और जबरदस्ती नहीं conventional that is called conventional
that is a convention but actually electricity is flowing from negative electrode to positive electrode that is electron
current that is electron current
drift speed to the positive electrode but
that is electron current that is electron current
that is the real
yes
basis of current
that cannot flow from positive to negative
kintu convention physics or convention hala it is opposite to the direction of electron
exactly that is what now considering the direction of flow of electron only that can flow from negative to positive
yeah
but it cannot flow in opposite direction
no
it cannot flow so that's why it's not vector when you are considering electron that is one concept when you are considering current that is another concept
yes I agree whether you take conventional or electron but it goes in one direction
yes that will go in one direction
and moreover vector addition principle
okay I want to take go to the next question Pritam has asked one question why earth acts like a bar magnet so this is actually Pritam are you there yes
very much
you see why earth is a magnet that is still a mystery but so that the concrete explanation is not known there are so many explanations first explanation which the earth consists of so many materials earth cross trade maximum amount of iron but it a basic thing iron to maximum if you go to the 3000 kilometer is solid rock then 2000 kilometer 5000 kilometer it is 6400 kilometer center distance but 3000 to next 2000 lava or liquid molten stage रे अछि सेतरे सब आयरन पार्टिकल्स मन पर तार कंसीडर अछि I'm not considering rock रे मध्य iron होउची. Now see these particles iron रो जोची you see domain concept ता सेटा साथ तुमको भला भाବରେ बुझेई चंती सेथिरे मध्य तमने magnetism develop करूची. But this explanation is not satisfactory. So what is the next explanation? The explanation you have studied today. The charged particle, when it moves, it creates a magnetic field around it. Jete bada charged particle rest nahi move karuchi. It is a relativistic concept. Move karuchi. Setebale se the charged particle a magnetic field create karuchi. So after the molten stage re jaha achi, they are continuously in the state of motion. And also Earth to make the atmosphere achi, you know there is an ionosphere. And there are charged particles in the atmosphere. See, charged particles, they are in a constant flow. Sabode motion rachu. So, charipate sabode a magnetic field created. And the maximum magnetic field, they're cancelling with each other. But when they are added together, it is observed that the alignment of the poles, so they're forming short magnets, but dipoles from one end to other. If you go on adding, they're aligned in a particular direction, and that is called the magnetic axis of the Earth. So that is one of the plausible explanations that Earth behaves as a magnet due to the flow of charged particles. The charged particles present in the Earth and Earth's atmosphere, a magnetic field is being created. And quote and North Pole, South Pole, Tripathy research. Another explanation is that Sun has a magnetic field. Sun is a magnetic field. And Earth is inside the magnetic field of the Sun. So Earth has developed, Earth has ferromagnetic substances, so it has developed a magnetism inside it. And that is the reason why there is a change in magnetic field. Always there is change in magnetic field in the Earth. When there is sun flare, you see there is magnetic storm in the polar region. The man studied through a magnetic storm. Polar region, a colorful sky becomes colorful. Like the rainbow type of bluish, yellow, green color, entire sky, they look like they become colorful and they flutter and they holu. Sometimes it becomes very colorful. That is magnetic storm. So that is the most practical example that Earth has a magnetic field. And practically also you can suspend other things in. I'm not going into detail. Yes, okay. Are you satisfied, Pritam?
Do you have any other question now? Om Sai, I will ask you to ask the question at the last. Aukar achiki, Devi Datta Brahma, Vishnu ko sangare, आउ महेश्वर को संगे तमे जदि करिवो खाली मीटिंग आम पाखु आसीबनी केमति हबो प्रभाव किछि अछि कि ये अनिल सर आउ ओके
सर हमें
अच्छा
हां
हमें सब छाडी छी सर हम डाउट गुडा को चैट बॉक्स सर से सर देखिन सर टिके
यस चैट बॉक्स रे मु देखुनी देखिलो चैट बॉक्स मोटे मु देखुनी yes. Let me read out chat box, Dr. Mishra. When Dr. Mishra is with me, I'm confident, overconfident, because nothing bad will happen. Sir, when Earth acts as a bar magnet, you know it's a bar magnet towards battery. Sir, towards battery mane kono? Eta ki Om Sai mu pacharibi. Acha, why is not vector when current flow? Solid. Anil sir, namaskar. Which is the null space? What is a null space? How can we find the null space? Acha, sir, can field lines intersect? No. Field lines, the rule is that never intersect. Never ever intersect. So you can yourself map out. You will find they will never intersect. Among so many metals, why only some metals are magnetic property? Yes, this is Om Sai. Sorry, Pritam Das. And that question I will answer with the permission of Dr. Mishra. Sir, why sun has magnetic field? And Pritam Das. Sun has magnetic field. And Om Sai, what is the process of magnetization? Are they different for permanent and temporary magnets, strong and weak? मु सेइथरे प्रीतम क्वेश्चन रे मु आंसर देबी सर कैन फील्ड लाइंस इंटरसेक्ट नो सो खाली गोटे रहिला जे सन एज ए मैग्नेट एंड null space. Can we talk about null space? I don't recall what is a null space. I can talk about dark energy, dark matter, but not about null space. Let us forget that. And let me tell you before Dr. Mishra takes over from me with my question, because I have a question, doesn't matter. I would request him to, so that restrict to 1 hour 45 minutes. It's already 1 hour 30 minutes gone. Now see, Pritham and Om Sai and others who are listening directly from the Zoom, and those who are watching remotely or will be watching later, many watch later. Let me tell you, ferromagnetic substances are unique. माने तीनी भाई फेरो फेरी मैग्नेटिक आ गोटे एंटी फेरो ये माने ये होची बड़ो भाई एथरे कोन होची एक्चुअली दी unpaired electrons. You all know that the molecules and atoms, they carry electrons. They're paired in inner cells. बाह्य कक्षरे किछि जदि unpaired electron थिबो, that is the presence of magnetism. Remember, जदि unpaired electron किछि नथिबो, that can be a magnet called diamagnetic. से magnetic field रे उल्टा repulsion हो, तार unpaired electron नाही. The so called magnetism, it will not show. Magnetic materials, they will be attracted by a magnet. They will be slightly repelled, so they are called diamagnetic materials. Are unpaired electron 9. All electrons are jugmito paired. Ferro re kon interesting jinso dekho, there are lot of domains. Say domains re jo free electron udako, jo unpaired electron, not free, unpaired electron udako same direction rachati. They are aligned in one direction. And it out direction re. These are called domains. It out direction re. Jota onyo manakar na it out direction re. But highly oriented domains are present in ferromagnetic material. Acha jette bele ame taku gote strong magnetic influence rakhiba, will make it a core, gote solenoid ro core kariki detere you kariba, current pass kariba, and produce a temporary, electromagnet, that is called electromagnet kariba. Se soft core re, se core re, iron core re ba je kono si ferromagnetic material ro core re, jo domains udako bhinna bhinna direction re achanti, they will be aligned in the direction of the magnetic field, external magnetic field. आउ जब सेटा हार्ड थिबो, अल्निको टाइप रो बेनी एलॉयस जो कथा कहिली, से माने परमानेंटली अलाइंड हे जिवे. बाहर कला परे मध्य भी ए डोमेन्स उडा को they will be permanently aligned, गोटे डायरेक्शन रे अलाइन हे जिवे, एवं they will produce a pole, गोटे पोल हला नॉर्थ, गोटे पोल हला साउथ, जणा पड़ जिवो टेस्ट कर देले. किंतु ता सानो भाई फेरी रे सब अप एंड डाउन, गोटे अनपेड इलेक्ट्रॉन ऊपर, गोटे तळे, गोटे ऊपर, गोटे तळे, किंतु तळ संख्या कम, ऊपर संख्या अधिक. So ultimately vector sum resultant is there. So ferromagnetic was the first natural magnet. Ferrite material or lodestone एगुडा को सब प्रथम माने प्राकृतिक मैग्नेट ताको टाणी बसे, किछि मैग्नेटाइज करबा दरकार नै. से मानकर नेट मैग्नेटिक मोमेंट अछि, बिकॉज तांकर तळ ऊपर अल्टरनेटली से माने अप एंड डाउन रहि करी मध्य, किंतु नंबर ऑफ अप्स आर लिटिल मोर देन नंबर ऑफ डाउन्स. So ultimately there is some residual magnetic moment, which it is by birth they are magnetic but small magnetic. ताकू मैग्नेटाइज कले, ताकू कोर हिसाब रे रखिले सी हबनी, टेम्पररीली हबो. जेमति इलेक्ट्रिक माने करंट बंद कर दबो सेते बेले आउ से हबनी. इट कांट बी कन्वर्टेड टू परमानेंट मैग्नेट. होची फेरी मैग्नेटिक. तादर अन्यतम होची ए लोडस्टोन मैग्नेटिक ऑक्साइड. तार सबा सान भाई होची एंटी फेरोमैग्नेटिक. से गुडा केतोडा मटेरियल अछि, माने बहुत लो टेम्परेचर, ताकर ऑर्डिनरीली एकदम माने वेक्टर सम टा जीरो जो मैग्नेटिक इंडिविजुअल इलेक्ट्रॉन मानकर अनपेड इलेक्ट्रॉन मानकर पोल्स देबन एमिति ओरिएंटेड थांती अप एंड डाउन तो नेट इज जीरो आर तो नेट टा नॉन जीरो टिके ना को अच्छी यार नेट टा मैग्नेटिक मोमेंट जीरो किंतु गोटे लो टेम्परेचर को नेले कार -20 कार -50 लो टेम्परेचर ताको नेल्स टेम्परेचर ता तळु को नेले मैग्नेटाइज कले टिके मैग्नेटिज्म डेवलप हबो टिके अट्रैक्शन हबो से टेम्परेरी एवं एमानकर यार थाए नील्स टेम्परेचर एमानकर दी जनकर थाए क्यूरी टेम्परेचर ए दी जनकर फेरो हीरो मार्का होची फेरो देन तार सानो भाई फेरी नेचुरल मैग्नेट जोडा यांकर थाए क्यूरी टेम्परेचर जो टेम्परेचर को ऊपर को उठी देले से माने आउ तांकर मैग्नेटिक प्रॉपर्टी लूज करिवे दे बिकम पैरामैग्नेटिक आउ गोटे जिंस वाला पारा पारा माने कोन जे प्रथम ना डोमेन अछि ना किछि अछि दे ऑल द इंडिविजुअल इलेक्ट्रॉन्स मोमेंट आर रैंडमली स्कैटर्ड इंडिविजुअल इलेक्ट्रॉन्स मोमेंट उडा को दे आर रैंडमली स्कैटर्ड म्यू नेट इज इक्वल टू 0 एवं से माने गोटे मैग्नेटिक फील्ड अंडर रे आसिले टेम्पररीली दे आर अलाइंड बट पुनी छाड़ देले पुनी से डिसओरिएंटेड हे जिवे पुनी नॉन मैग्नेटिक हे जिवे सो दिस इज कॉल्ड पैरामैग्नेटिक यार म्यूटा 0 नेट म्यूटा 0 मैग्नेटाइज हे परिवनी सो टेम्पररीली मैग्नेटाइज हे परिवो तो ए माने समस्त फेरो जे हीरो मार्का बड़ो भाई तार कुनी भाई ए दीटा को दे लूज देयर मैग्नेटिक प्रॉपर्टी टू बी permanently magnetized or temporarily magnetized in this case तार सब मैग्नेटिक प्रॉपर्टी जीवो लार्ज पार्ट जेतले तमे गोटे पर्टिकुलर टेम्परेचर को हिट करिवो तार आयरन तमे टाणुची कोन जेते जोर रे टाणुची बट नो जेतले आयरन को 1000 डिग्री सेंटीग्रेड को हिट करिवो आयरन सी हाउ टाणीवोनी इट विल बी बिहेविंग एज ए पैरामैग्नेटिक स्लाइड टाणीवो से किछि नु सेटा गोटे एक्सपेरिमेंट कले जानि परिवो स्लाइड बट तुमको जाना पड़िबन जेम भटकिन लागि आस्तिला 1000 डिग्री ऊपर को नेले आयरन टा को ततेइले एवं मैग्नेट गोटे रखिले हर्सु मैग्नेट किछि टाणीबो सो दैट इज कॉल्ड द क्यूरीज टेम्परेचर ओके दैट्स ऑल सो आउ किछि रहिला
let us take the questions asked by the participants.
Participant la null
one is this among so many metals why only some metals show magnetic property. This is actually the origin of magnetism. If you go to the origin of magnetism, so that differentiated according to their property of magnetization, ferromagnetic, paramagnetic, diamagnetic, ferrimagnetic, all these things. But what happens that the origin is this motion of charged particles. This was first explained by Einstein on the basis of theory of relativity in 1905. So he considered that magnetism arises completely due to relativistic motion. If you move with a charge, suppose you are carrying a charge and you are moving, then that charge particle is creating no magnetic field around it for you. But if you are the charge particle is moving with respect to the surrounding, with respect to the frame, then that is creating a magnetic field. And why it is creating? That is due to the internal structure of the atom. And inside atom, there are, you see, electrons. And electrons have two types of motions. One is spinning around its own axis, and another is revolution around the nucleus. Now, both will describe magnetic fields. But the spinning motion, the rotation of the electron about its own axis, that creates more magnetic field because that is interacted with the spinning of the neighborhood electrons also. So it is found that if the spin is in the same direction for 2 or 3 or 4 electrons, then the magnetic field produced is more. And if the spin is in opposite direction, the magnetic field strength will be less. And it has been found experimentally that for iron, there are 4 electrons. For iron, there are 4 electrons which are spinning in the same direction. They do not cancel with each other. They are not cancelled. We do not use the term not cancelled. We use the term on cancel. they remain as uncancelled.
Excess.
Yes. So that produces this magnetic field. That is why the iron is the most magnetic substance.
These are like domains. These are
Domains.
domains.
That creates domains. Okay. So next question is why sun has magnetic field? That is what we are discussing. The sun has huge number of ions, the charged particles, gaseous substances. So due to that, they are in the plasma state, all these things. So high temperature, the ions are there, charged particles are there. So since these charged particles are under motion, so they create magnetic field, and it has a huge magnetic field around it.
You know,
Next.
continuously fusion reaction is coming.
Yes,
Saying protium, deuterium, they are fusing and getting a lot of energy. So these ions, they generate electric and as well as magnetic field.
Okay, next question is, what is the process? Question is by Ohmside. What is the process of magnetization? That is what if you take a magnetic substance and place that inside an external magnetic field, then what happens? These magnetic dipoles, they get aligned in particular direction, in the direction of the field applied, or in opposite direction, whatever. So it's alignment hoche samaste gote direction apply hochindi tale gote north south. So majira north south cancel hochi, end north and last south, they prevail, and that creates a magnetic field. That is why they get magnetized. Then there is a question of intensity of magnetization, all these things. Are they different for permanent, temporary, and strong temporary magnets? No, it is not different. Only in the case in a permanent magnetization, they remain as it is. Even it is mishandled or temperature is raised, the magnetization is lost drastically. So some magnetization remain inside it. So that's why it becomes a permanent magnet. Temporary magnet, electromagnet is a temporary magnet. So it acts for a certain period, and then if you remove the current, all these things, then its magnetization is lost. That is temporary. And strong and weak, again the same thing. Strong magnetization means the length is not large. When the dipoles, the north pole, south poles, this north pole and south poles, they are aligned side by side. Suppose this is the direction in which they are aligned. If this width is large, then large number of dipoles will be the north will be there. This side will give you north, and this side will give you south. That means if you break this into two parts, the strength of the magnetic field will not decrease. Length doesn't matter. This matters. How much dipoles or the small magnets are there placed side by side. The strength of the magnetic field will be large. Okay, that is a strong and weak magnet.
Okay.
Next is
earlier,
yes.
Guys, earlier there was a single touch method, double touch method, manual methods were there. You know, if you take a ferromagnetic material and then take a strong magnet, I mean a permanent magnet, and go on, touching it in a very rhythmic manner, touching it and rotating it. So we were trying to align the domains and getting. Nowadays, electromagnetism method is being mostly used. Please correct me if I'm wrong.
Okay, sir. Next question is this question already being answered. Can field lines intersect? If not, why? Field lines, they cannot intersect because field lines means what? These are imaginary lines. Just the direction of the force of the field from one end to the other, from north to south. Or inside, if it's a magnet, inside the magnet is from south to north. So you are finding the directions at any point, and if you draw the tangent at that point, so if you sparshaka draw kariba, so sparshaka by tangential direction, that gives you direction of the magnetic field. Same point for magnetic field direction side. And gote point re jodi dita intersect korchandi, tane ei field line pai ei point re field direction yade, or ei field line pai field direction epote. মানে দুইটা ভেক্টর গোটে পয়েন্ট রে দুইটা ডাইরেকশন which is ambiguous. So দুইটা ডাইরেকশন গোটে পয়েন্ট রে হেই পারিবনি. So that's why field lines, they do not intersect each other. Another question, most probably Nigar sir, Anil sir, mostly null space. What is null space? How can we find the null space? So actually, space and vacuum is different. Space and vacuum, usually we call space and vacuum same thing. Space and vacuum are different. Space, any point in the universe will be called as a space. Okay, and this electromagnetic field, they are all pervading. Everywhere this field is present. So magnetism arises due to charged particles, and all these galaxies, they have charged particles. So magnetic field is there. But when the magnetic field at one point is cancelling with the magnetic field of the other, if they're in equal and opposite direction, at that point resultant field will be zero. So the space, the position at a particular instant of time, space and time are interrelated. Only space ko time included. So when at a position, at a given space, at a particular time, the field lines or the strength of the field are equal and opposite. They cancel with each other. So that point is basically known as a null space.
That's great.
Okay.
Right.
Can I ask some questions to the students?
Oh, well,
if we have time.
We are getting late, Dr. Mishra.
Okay, I'll ask one question. They take it as homework. Take it as homework. Yes.
सर जे पृथ्वीटा महाकाश रे जतबेले रहते से सूर्यंक द्वारा भी आकर्षित होचे आ पृथ्वीर निजर आकर्षण शक्ति द्वारा भी आकर्षित होचे तो से कोन से नॉल स्पेस रे रहचे से झुल्ली के रहचे से कहीं गाली पड़े
null space null space yes, null space gravitational force is something different that arises due to mass only. वस्तुत्व जोगु gravitational force आसे और gravitational force टा गोटे बहुत दुर्बलिया force. It is the weakest force. It is the weakest force. हमें जो null space कथा कहूचे, that is due to the resultant magnetic field, not gravitational field.
तोरा दीटा मैग्नेट रखी छ एप्टी डायरेक्शन रखी यार और मैग्नेटिक लाइन से तक पूरा इंटरफियर करके एग्जैक्टली कैंसिल हो गला सही पॉइंट रे द रिजल्टेंट फ्लक्स डेंसिटी इज 0 सो सही टाको हमें परहैप्स आई हैव अंडरस्टूड प्रॉपर्ली इट इज द नॉन स्पेस
सर पृथ्वीटा कोन सही पॉइंट रे
अरे बापो बायाणी सेटा हला ग्रेविटेशनल जिंस पृथ्वी सो चंद्र को टाणुची चंद्र पृथ्वी को टाणुची सूर्य पृथ्वी को टाणुची पृथ्वी सूर्य को टाणुची सेउडा होसी ग्रेविटेशनल मैग्नेटिक सार कहिले मैग्नेटिक फोर्सेस are extremely small and negligible.
Okay. अच्छा पिला माने तमने पढिलो जे करंट थिले ता चारि पटे मैग्नेटिक फील्ड हबो मैग्नेट थिले ता चारि पटे मैग्नेटिक फील्ड अछि अच्छा तम पाखरे गोटे रिवॉल्वर माने कर अछि तमे ताको धरिलो तम छात आडी की पॉइंट करिकी गोटे रिवॉल्वर धरलो एम धरलो अच्छा से रिवॉल्वर गुली बाहरिबो से गुली बा इलेक्ट्रॉन बाहरिबो you fire electrons तब छाता आडी की जते ट्रिगर करलो इलेक्ट्रॉन रा धाय धाय मशीन गन भलिया बाजला सो तले इलेक्ट्रॉन गुडा जाउची छाता आडी की सेते बेले सेही जागा रे मैग्नेटिक फील्ड क्रिएट हबो ना नाही जदी हबो काहे की हबो जदी न हबो काहे की हबो आउ जदी न हबो काहे की हबोनी आउ जदी हबो ताले ता दिग कोन हबो if the time nahi, you can think and you can answer it in the next.
Yes, we have. I have deliberately left, boys and girls, ladies and gentlemen. I have deliberately left the principle of motor, and so that because of the paucity of time, I left it, and that will be discussed next Sunday. And because next Sunday we have a lot of time for discussion, I'll take a very small time for the motor principle and then switch over to generator. And if that can be prepared, because he is having some problem with his sharing screen, and I would have invited Dr. Mishra to revise that in haste and then go for discussion. I would have rested a while. Next time we'll be going for the motor principle. Tomorrow course re khali DC motor achi. We'll talk about AC motor. How a three-phase line is motor fan buluchi, that is not a DC motor. It's not working on a DC battery. It's working on AC line. How it is converted. So that also elementary टिके नॉलेज तुमको दिया जीवो as well as the generator the EMI principle सेति पय मु आज छाड़ देली आउ मोर गोटे को क्वेश्चन थिला हिस्टेरिसिस जो मैग्नेटिज्म रे सेटा तारो कॉन्सेप्टटा एंड से पिला माने जानंतु एवं सेटा डॉक्टर मिश्र ताको बुझेइबे and many other questions we will take up. Already we have crossed 1 hour 45 minutes. It is very monotonous, although ଆମ uranium ପିଲା ମାନେ ଏପନ୍ତ ଧୈର୍ଯ୍ୟରେ ରହିଛନ୍ତି, but it is for others it will be really difficult. Okay, ଏଇ क्वेश्चन ର आंसर के देई परिबे कि सार कर एबे न दले नेक्स्ट टाइम दबो ननी सार आंसर देबे क्विकली दबा को पड़िबो, so another 2 to 3 minutes we can afford. सार कहउथले इलेक्ट्रॉन गन रे मैग्नेटिक फील्ड होची ना होनी और बहुत होची let me give you a hint और बहुत होची not hint for the answer by way I would add करूची to confuse you. Well, आपण कोंतु डॉक्टर मिश्रा they are stark silent.
अच्छा अच्छा और पिलाने अच्छा ना नहीं raise your hands. अच्छा अच्छा so electron has such, okay, so since the electron is moving upward towards the roof, suppose, then this is moving, so it creates a current. So as the electrons are moving upward, negative charges are moving upward, it creates a current downward, as if a wire is there hanging from the roof. I'll say where the current roof ru tala adiki move koruchi. Tale current bartan ei bhaliya move koruchi. Current bartan ei bhaliya asichi. Emti asu ta current. So current thel achi mane ethre current achi mane ta chari pate magnetic field achi circular shape re. ये जति अछि माइनस z एक्सिस रे ताले xy प्लेन रे बर्तन मैग्नेटिक फील्ड अछि and direction of magnetic field here it is in this, here it will be this one, and ए जगह रे बाहर बसते ए जगह रे एडिट बसते. So there is a magnetic field around it, so it creates a magnetic field. Got it?
That's a very simple question. I could not answer.
And that question for 8 nathila, but the next question is that if you are firing from two revolvers, electrons moving like this, what will happen to this ray of electrons moving? Will they be attracted? Will they be repelled? Or will they remain as it is?
Same.
This is for the next class. This is for the next class.
Mind for
पाठापाठी अछंदी ए रिवॉल्वर इलेक्ट्रॉन ऊपर को जाउची, it creates a magnetic field. ए रिवॉल्वर इलेक्ट्रॉन याडे जाउची पाठापाठी
तमने obviously guys current direction ता सेम अछि towards from top to bottom, right? So बर्तमान आमे जानि छे सा principles same direction रहिले attraction होबो. This is my thinking. I may be wrong because I am not an expert in physics.
This we will discuss in the next class.
Okay.
So the electron beam गुडा कोन होबो, एमती attraction हेबे कि repulsion हेबे कि किछि हेबेनी कि जणा पडिबोनी कोन होबो, we will discuss.
कौन कहू आरत्रिका मैडम
एबे कहबा आरि बोलिया
विकर्षण हबो हे पारे सर कहबे एक्सपर्ट will give his decision next time ना एबे.
Sir, I also think repulsion will happen.
हे पारे टिके टिके
सर विकर्षण
मते लागुची repulsion हबो सर.
प्लीज एक्सप्लेन जदि कथा पडलानी प्लीज एक्सप्लेन.
आकर्षण होबो
नहीं प्लीज एक्सप्लेन. इफ यू आकर्षण प्लीज एक्सप्लेन. प्लीज इफ विकर्षण प्लीज एक्सप्लेन. तुम पाखु दियाहला आकांक्षा कहूची आकर्षण
जहाँ भी होची आकर्षण विकर्षण काहे की हो जस्टिफाई.
ओके नेक्स्ट टाइम समस्त को दे देबा नेक्स्ट टाइम ना एबे कहिबे आपण 2 मिनिट
सर गोटिए दिगरे जाउची
ना आउ कोन थिबो ना से सार आ भितरे अन्य किछि रहस्य थिबो ना नने सार एते सहजिया क्वेश्चन पचार थांते निश्चय आम आर्थर कहवा ऑलरेडी आम वी आर इंचिंग टुवर्ड्स 2 hours. Oh my god.
Sir, may I try?
Now, so अच्छा न्यूट्रॉन गन जब छाड़िबो कोन होबो जदि जस्ट इलेक्ट्रॉन गन छाड़ले जदि न्यूट्रॉन गन छाड़िबो will it produce any magnetic field? Answer is no. So because neutron is neutral. So ladies and gentlemen, boys and girls, and I'm sure this will go a long way. Our video will be watched by many in future also, because many they do not watch on live, they watch later times. So next Sunday at same time, 7 o'clock will be the end of our electricity program. And we will plan together, Dr. Mishra and myself, how to execute that. For now, from me and Dr. Mishra, my colleague, we are signing out. Bye-bye.
Bye. All the best.